Welcome back to the channel. It's been a good few months since I last posted. I started to make a video on a nice little CNC project for the kitchen, but partway through filming I discovered more damage from a recent flood we'd had, and it resulted in the whole kitchen being ripped out, so I had to put the video on hold. I took this opportunity to make a few improvements to the kitchen and decided to knock through the kitchen into the little office I originally had and created a walk-in pantry. The kitchen refurb has literally taken up all my spare time, and I've still a long way to go before it's finished. I took a few clips of the progress so far and I'll play that while I'm chatting. But a few weeks back I was browsing through the online forums and a question I saw often was, if I buy a CNC, how long until I can make a return on my investment? It got me thinking, because yes, they can be used to help make you money, but there's nothing wrong with just buying one to be used as a tool or a machine in the workshop like any others that you buy without question. I'll buy a tool because it's useful or because it makes a job so much easier, and for me the CNC is no different than most of the other tools or machines that I've ever bought. That's not to say it hasn't paid for itself over the years. I think what I'm trying to say is that you can buy a CNC for pleasure, not just for work, just as you may do with a wood turning lathe for example. A lot of lathes cost the same as a CNC these days, and most of us just tend to buy a lathe as a hobby, making pens and balls for fun. So I thought, whilst I'm getting my kitchen sorted, if there's an opportunity to make something on the CNC that'll either help during the build or as a useful item around the kitchen for when it's finished, I'll just make a little video or tutorial if it's relevant. Aim more at beginners really. But it'll hopefully show that a CNC can be used around the house for little DIY projects and not just as a means of making money. For my first project it's something really simple. We bought this fridge freezer, but unfortunately it can only be adjusted at the front, and the back needs to be raised about 13mm. I managed to level it with a courser that I'd made, but using wood underneath the freezer isn't ideal. I'd recently bought some HDPE and wanted to see how it machined, so whilst I could just cut a piece off with a handsaw, it was a perfect opportunity to switch on the CNC and experiment a little. For all my machining now I use Vectric Aspire. I find the software is easy to use and there's a really good online support network too, with all the various Facebook groups, YouTube videos, and of course Vectric themselves. I'm using Aspire, but this is a basic project, and I'm pretty sure this will be similar on other versions of Vectric. I will add that this is an extremely basic project which could be done very quickly by hand to some extent, but I just wanted to see how the HDPE cuts, and this is a perfect excuse to try it on. So on opening Vectric, click to create a new file. Job setup comes up first, and I have my job set up as single-sided with a width, height and thickness that matched my workpiece. And the Z0 position set to the top of the material surface. I'll be setting everything from the centre of the material so that my XY datum is set in the middle for X0 and Y0. I'm happy here, so I click OK. All I need for this project is to make a simple rectangular piece, so in Create Vectors I'll click on the Draw Rectangle icon. I want the anchor point set in the middle and with a width of 80mm and height of 60mm. I wasn't sure about the corners whether or not to add a radius, so just leave it be. If you click Radius to External and set it to 5mm, you'll get something that looks like this. If you set it to Square, it'll look like this. I originally set mine up as square, but then decided to add a radius. Could have just highlighted the rectangle and gone back into the Draw Rectangle vector to add the radius, but I used the fillet tool which worked just as well. I'm not sure if there's a reason to choose one way or the other, but maybe let me know in the comments. Now, it'd be a waste of material if I just cut the shape out here, so I moved it. Before I place anything, I like to see where my fixing holes go, so I tend to use the guides and place them where my screws will go. I like to add 10mm circles to represent the screws that will hold the material to the machine bed, and that'll hopefully be a guide as to where not to place my vectors so as not to end up machining through the screws later on. To move the rectangle, I click on the vector and I can use the arrow keys to manually position it. Or I can click on the Move Selected Objects under Transform Objects. And if I know the coordinates I want to use, I can use the Absolute option and input the numbers in the X and Y boxes, which in this case were -85 and 95, and clicking Apply moves the rectangle to its new position. And that's it for the design, really simple. The icon at the top switches the view to Toolpath commands. The only toolpath operation I'll need is a profile pass which will cut the piece out. Ideally, I'd use a thinner cutter, but this 8mm cutter is the thinnest I have at the moment. I have my cutters set to cut just small amounts at a time, and they'd certainly cut more in one pass, but I'm always wary of cutting too much and snapping the cutter, so I've always stuck to light passes at the sacrifice of adding more time to the machining. I'll need to add a couple of tabs to stop the piece flying off during machining, and with the software it's a piece of cake to set that up. Previewing the toolpath will give me an idea of how it will look and all seems good, so I'll save the file and machine it at the CNC. I wanted to experiment a little bit, and I was interested to know if a piece of rubber would stick to the HDPE using carpet glue, as I'd previously tried super glue and it didn't stick. This was more for use in another project that I've got planned, but now is a perfect chance to test it out. The HDPE machined really well, but I messed up a bit because although the combination of rubber and HDPE did machine well together, it didn't allow for the extra thickness when machining, so the tabs were created on the rubber and not the HDPE, and the piece came loose, which resulted in the HDPE chipping at the corners. But not to worry, I went ahead and machined the piece without the rubber and it came out really well. I've swapped this for the wooden piece that I placed under the freezer and now it sits as it should do. Yes, it's overkill, but it does the job perfectly. It won't ever rot if there's a spill on the floor, and more importantly, it got me back on the CNC. There's a lot more work to be done in the kitchen, with more kitchen related CNC projects on the way, so feel free to check back if any of this is any interest to you. Thanks for watching, and if you've any questions, just let me know in the comments below.